What if mountains could walk and eat leaves? But these were the largest animals ever to walk the earth. We are tracing the lineage of the giant sauropods. But their size was a direct response to the plant biomass available. Gigantism provided unparalleled defense against apex predators. But these herbivores faced unique biomechanical challenges just to stand. Now that we understand the challenge, let's explore the largest contenders. Our first Titan contender is often estimated near 80 metric tons. This massive body required an equally massive digestive system. They needed to consume hundreds of kilograms daily, constantly eating. Digestion was slow. Fermentation was key to extracting nutrition. The sheer volume of waste produced drastically altered the ecosystem. Their teeth were designed for shearing, not chewing efficiently. A vital evolutionary constraint was the relatively small head size. Pumping blood 60 feet upward required extraordinary cardiovascular adaptations. Drinking was a critical, vulnerable moment for these giants. Their eyes, though large, likely saw a world of greens and browns. And now that we understand the mechanics, let's explore the true giants. One genus, characterized by its incredibly long tail vertebrae, takes the crown. Its mass estimate pushes the known upper limits of terrestrial locomotion. Evidence suggests their skin was incredibly thick, armored by dermal ossifications. Walking was less a gait and more a controlled, deliberate fall forward. They likely moved in herds, offering collective defense through sheer bulk. Their massive exhales likely influenced local atmospheric conditions. But even the young were large, hatching much bigger than most modern mammals. The energy required to sustain this mass was astronomical and unending. They relied on gastroliths, stomach stones, to aid mechanical digestion. This constant need for fuel shaped entire continents' flora. The sheer energy devoted to feeding meant little energy for other activities. The neck vertebrae possessed complex internal struts to maintain lightweight strength. Now that we understand the long necks, let's examine armored titans. These stegosaurs relied on defensive morphology rather than height advantage. The tail spike arrangement was evolutionarily refined for active defense. Debate continues whether these plates regulated body temperature actively. Not all giants were quadrupeds, sir. Some utilized specialized bipedal feeding niches. The duck-billed herbivores employed complex dental batteries for efficient cropping. Crests and frills suggest social signaling played a crucial role in herds. A hollow crests acted as intricate resonating chambers for deep calls. The environment dictated their forms as much as predator pressure. There, seasonal migrations likely followed the availability of nutrient-rich foliage. The sheer mass meant their bones were densely packed, yet surprisingly porous. But this density was necessary to support weight without fracturing under stress. An airflow within their bodies involved an avian-like system of air sacs. The brain, powering this immense body, remained surprisingly small proportionally. On survival was automated eat, move, grow, avoid immediate threats. Their slow pace reflected the immense energy conservation required. And the outer armor was primarily passive, relying on sheer thickness for protection. These species may represent the absolute physical limits for land animals. Their enormous size fundamentally shaped the structure of Mesozoic forests. They were ecological engineers, constantly pruning and shaping the landscape. Only the largest marine mammals rivaled their sheer biomass today. The wood they consumed was tougher than anything we process today. The growth rates were incredibly fast, moving from small to enormous quickly. Understanding these giants relies on painstaking, massive fossil recovery efforts. Every fragment tells a story of successful evolutionary adaptation. The success of the sauropods spanned hundreds of millions of years. They represent a biological peak of sheer, sustained herbivory on land. Their lifestyle demanded unwavering consistency in resource acquisition. But they mastered the art of being big in a world built for giants. These colossal herbivores remain the ultimate testament to evolutionary scale.